In this video, we are going to see examples of how to find the complementary function. Complementary function, which is first part of solution of linear differential equation with constant coefficient. We are going to see first part of this solution, how to find YC. We have seen the procedure. We are going to see examples in this video. Let the given differential equation is d square y by dx square 2 dy by dx plus 5y is equal to 0. While finding complementary function, we are keeping the right hand side of equation as 0. Because by keeping right hand side 0, whatever the solution we get, we call it as a complementary function. So first write this equation using operator d. So this is d square y, d of y, no derivative, so only y. Taking y common, whatever bracket of d we get, equate it to 0, we call it as a auxiliary equation. So auxiliary equation is d square plus 2d plus 5 is equal to 0. Find the roots of this auxiliary equation. Now we cannot find factors of 5 such that the addition is 2. So we have to use the rule minus b plus minus square root of b square minus 4ac divided by 2a. Rule of ax square plus bx plus c is equal to 0. So values of x are minus b plus minus square root of b square minus 4ac divided by 2a. Using this root, we are going to find values of d. So this minus 2, this square root is minus 16 divided by 2. Square root of 16, 4, square root of minus 1 is I divided by 2. Divide separately, we get minus 1 plus minus 2i. As I said in the earlier video, whenever we get imaginary roots, we always get it in a pair. So the corresponding CF, so two values of D, so CF or complementary function YC is written as a real part in the power of exponential term and imaginary part in the angle of cos and sin. C1 cos 2x plus C2 sin 2x when the roots are imaginary. Let's see one more example. Let the given differential equation is d square y by dx square minus 5 dy by dx minus 6y is equal to 0. So first write this equation using operator d. Taking y common, equating this bracket of d to 0, we get auxiliary equation. Find roots. Roots of this factors of 6 such that subtraction is 5. These are 6 and 5. So d minus 6 and d plus 1. So roots are, for first bracket it's 6 and for second bracket it's minus 1. So which case is this? Case 1, where the roots are real and different. For root 6, C1 e raised to 6x. For second root, C2 e raised to minus x. This is first case, roots real and non-repeated. Let's move to next example now. D cube y by dx cube plus 2d square y by dx square plus dy by dx is equal to 0. So first part, write using operator d, taking y comma. Equate this bracket of d to 0, we get a auxiliary equation. Find the values of d now. Since the degree of this polynomial in d is 3, we will get how many values? 3 values of this equation. Taking d common, taking factors of this bracket, which is nothing but whole square of d plus 1. Equating each term to 0, we get for d 0, for d plus 1 minus 1, and for d plus 1 minus 1. Now in this case we are getting 3 roots. All the 3 are real, but 2 roots are repeated. So first write down term for non-repeated root, c1 e raised to 0x. Then for repeated part, c2x plus c3 e raised to minus 1 into x, which is c1 plus c2 plus c3 into e raised to minus x. So whatever the degree of this auxiliary equation is there, that many roots we are getting in the solution, and that many constants are there in the complementary function. Let's move to next example. Let the differential equation is d square plus 1 whole square of y is equal to 0. The equation is already written in operator d. Now equate the part of d to 0. We get auxiliary equation. Find its root. Square is d square plus 1 into d square plus 1. Equate each term to 0. We get d square as minus 1. So roots are plus minus square root of minus 1, that is I. Same for this part. We get d is equal to plus minus I. That is, we are getting this pair 0 plus minus I repeated. So imaginary pair repeated case is here. So e raised to real part into x. For repeated root twice, c1x plus c2 cos of imaginary part into x, c3x plus c4 sine of same angle. E raised to 0 is 1. So this is the fourth case, imaginary roots repeated. So similarly, so this is the way to find complementary function, which is first part of solution of a linear differential equation with constant coefficient.